Hey y'all. There's an old saying about how both fortune and misfortune are in fact two buckets drawing from the same well. That's on my mind right now. Rewind a few months to just before we got all this footage you're watching, and the 6.2 diesel in my Suburban just tried to split itself in half while on a drive back to Dallas from Austin. As I waited for the flatbed, the mental list of things that needed to happen continued to grow. The panic really started to set in as I had committed to bringing the truck on a series of spring and summer off-road events that were now only a short time away. So sitting there on the side of I-35, my thoughts were definitely drawing from that misfortune bucket. We had just 6 weeks to source, machine, build, swap out, and break in a new engine. It was a very tall order, but this is how we did it. Now, old GM diesels don't get much love. Designed in the early 1980s, the 6.2s were tuned for fuel economy rather than work. And 10 years later, the modestly warmed-over 6.5 was strapped with a super restrictive turbo, no intercooler, and not nearly enough fuel to live up to its potential. And look, compared to newer direct-injection diesels, they are really not that efficient. They're heavy. They're loud. They smell. And they are my absolute favorite.
Let's have it for me.
And look, you might be asking yourself, why didn't he swap in a Duramax or a Cummins or whatever? The short answer is that just doesn't interest me. Since my dad bought this truck new in 1985, this one-owner Suburban has always had Detroit power. And I like the idea of keeping it that way.
It should be pristine.
Plus, the engine gauge and subframe are all built around the dimensions of the 6.2 and 4L80. So I was really not keen to redo all that work, even if I do enjoy revisions. And so, my dad and I are now carefully disassembling this brand spanking new Optimizer 6500 from General Engine Products to prep it for duty in the Suburban. And look, I could have installed the 6.5 and run it as is. It is a great engine. But as y'all know, I cannot leave well enough alone.
Why do you disassemble a brand new engine?
Well, if you're going to go balance the parts and get some things done that are extra for it, it's got to come apart.
Because we think we can do it better.
Oh, yeah.
They build them and we make them work.
That's right.
After taking over production in the early 2000s, GEP incorporated a whole mess of performance updates to the bean counter homologated engines that GM produced through the 80s and 90s. And there are a few details that are important to us, like upgraded block metallurgy with thicker web mains, a forged crank that is a huge deal, improved cooling flow through the heads, and a thicker fire deck in the block. All these little changes, they add up, such that this design represents a meaningful departure from its predecessors. It is a very strong base recipe, and we're going to need it, because I aim to misbehave.
So we have everything back. What we dropped off was the entire rotating assembly, so pistons, rods, crank, and then all the stuff that bolts to it. So flex plate, balancer, yes, a brand new balancer, and even the hardware that attaches to it. So you need all of that stuff so that the people who are doing the balancing can weigh everything out and make sure it matches. We even dropped off rings to make sure that all the rings matched. And you know, there's some stuff that just like from the factory matches up pretty good, like the pistons. Not that there's a lot of room to take material off of these pistons, as we found out, but the pistons all pretty much match. I guess they go through and do a match set before they ship them to you. Now, the rods are a different story. Yeah, as the guys at the race shop told us, these rods, and all rods out of American engines is just what he said, these rods are crap. They don't balance at all. They're totally different. Yeah. And so we'll take a look at kind of how they get these things to balance real quick. So they find this rod probably was the go-by. See, that green mark came originally from the factory, which is probably a green mark that they use to indicate that the caps are torqued. But this is the balance pad right here. This material is excess on your rod, as is, flip over on the other end, as is on the top here. So this was probably their go-by. This is probably the lightest rod in the set that they then went and made all of these match by taking material off the balance pad. And these are really stinking heavy rods, which they need to be, you know, forged, handling, compression, ignition. But they, you know, find the lightest one and then they make all the others match just using a sander. And it's, as they were explaining to us, it's just back and forth between the sander and the scale. And they took adjustments off both the bottom and the top. So some of these that you can see here, like for number 3, is really rounded. And of course you got this oil port that cools the piston. They're matched, they're oriented, and you know, I think they'll come out all right.
For us, taking the time to balance the rotating assembly is an irreplaceable part of building a smooth-running diesel. Plus, this is a rare opportunity for me to get to build an engine like this, and so I am not likely to pass this way again.
We got the Total Seal second rings. This is actually the original ring. You can send these off to Total Seal, and they'll machine them to be gapless. We'll look at this here in a little bit as we start to put stuff together. But the cool thing is you want a gapless ring for your secondary compression ring on these. You don't have to go buy more rings. Just carefully take off the ones that you have, ship it to them, and not only do they ship it back to you modified, they take a great amount of care to make sure that they come back to you in the same packaging and condition, and they're all gapless. But we'll look at that here in a moment. I actually had 2 assembly lubes. This one came with some hardware, and it was just kind of interesting. This is the one that I had picked up. So we're going to experiment and figure out which one of these has, I don't know, tackier, thicker.
Oh yeah, the stickiest one.
All right, so Permatex is a little darker. Yeah, that's pretty good and snotty sticky. And the Amsoil stuff's a little thinner.
I think we can find a place to use both of them. But for sure the Permatex, a stickier consistency to it. It should cling theoretically better as we do the assembly. And the watchword is, use a lot of it.
Oh, if a little's good, a lot's better. So we kept track, WP1, wrist pin 1. We labeled everything, so we know exactly where it's supposed to go back. So I was trying to pull it out to get another screwdriver in there. I felt like I had part of it captured.
There you go. I think that's part of what has to happen is when you do this a couple of times, you'll see how quickly it goes together. And as long as it's centered in the groove and everything else, we're in.
I remember we just used motor oil a long time ago. We just squirted it with motor oil.
We did. Oiled it well.
Okay. This is number 1.
How about that? That's great.
That's pretty good. All right. Number. I'm gonna keep going on the odds, so so they get them all, the pins all oriented the same way.
Okay. Let's do number 3.
Rather than getting all back and forth. Okay, so you remember when we did white lithium grease before?
Oh yeah.
And what Dave was saying, he goes, you don't do white lithium grease these days. First thing I thought about was when we assembled the old engine, we used white lithium grease all over the place.
Everywhere.
Yeah. It's like, doesn't dissolve in oil. Oh, okay.
Oh.
Hot tip.
Okay, is that oriented correctly?
It is oriented correctly.
That's a pretty set of ladies, isn't it? We're all ready to go.
That's pretty cool. Let's get the crank. So we've got all the rods and the pistons are all together, and what we're going to work on now is getting out the crankshaft and starting to install the crankshaft and then marry the rod and piston assembly. Right now my dad's getting all the main caps ready, but before we go and put all that together, picked up a set of studs for all these main caps. So the 12 millimeter and 10 millimeter go from being a bolt to a stud, heavier duty, better material, and we're going to throw everything and the kitchen sink at this engine, including some really nice frou-frou hardware for the bottom end. Yeah. Gabe saw this, he was up there, he goes, "Hey, I saw a crankshaft with your name on it."
Really?
I was like, "Yeah, that was it." He goes, "It's a beauty." So let's talk about single parting lines and double parting lines. The original crankshaft on the 6.2 and 6.5s, the whole time that GM was making these engines for about 20 years, they came with cast crankshafts. And you can tell it's cast when you look at it because there's what they call a single parting line, which is to say the two halves come together, create a sharp point. Like for comparison, all of Ford's International or whoever actually made them, the 6.9 and 7.3 diesels, Ford's crankshafts all the way, Duramax, Power Smoke, Cummins, all of them forged all day long. So when we got this engine, what really sold it for me, because I was still trying to figure out what I wanted to do, was when I was talking to Travis at Rubber Duck 4x4, who sells a lot of these engines. He was talking about how the bottom end uses the forged crankshaft, which I had always thought, man, that's P400, that's only in the Super 6.5s, but in fact, I guess they did a part number consolidation, and now everything that you get, optimizer, if they ever make a P400 again, but all these optimizers are now using the forged crankshaft. So it's a little heavier duty, and it's got the characteristic double parting line right here. So anyway, but the crank you're looking at, we just picked up from the machine shop, and this is fully balanced, and they did a little bit of drilling out where you can see they took some material away. It was pretty close at the beginning, I guess is what they said. But they threw this on the balancer with the damper and the flex plate and the hardware that we brought. Got it all balanced, so this thing's, and it's super dirty. We got to clean it up before we set it in the engine. But just that quick note, should have been forged from the factory. It's the way Detroit Diesel designed it originally. And again, it took 20 years before this crankshaft was available to be forged, rather than just what we were stuck with as cast.
And now with everything balanced and cleaned and ready for install, we turn the block over and begin putting it all back together.
Loctite are we using?
243 medium duty, oil resistant. Say that one more time. What does it say?
Hey, the instructions are clear. It says, it is important that all stud threads and all load-bearing surfaces of the washers and nuts be coated lightly with the supplied lube. This ensures you get consistent torque readings.
Lightly.
If a little's good,
A lot's better.
yeah.
This looks like a bad jelly donut. One of the things that we were messing with was these, when we installed them, had, like, there was no thread that was visible. It was like this. They were completely collapsed in. If you read the instructions, they tell you to completely bottom this thing into the block, this end of the stud, and then, you know, go to town just tightening things down. But what you find out is you just don't have enough thread engagement up here. And so what we've done is we've gotten out one of the original main bolts as a gauge, as a tool. Here, show them. So that's where we've got to have the nut driven down. And so what we're going to do is we're going to install it using the, let's look at the hex. We're going to install the hex, and then we're going to tighten this thing down almost like you were lashing valves with a wrench and a socket. Then we'll torque. we figured this out only as we were going through doing the first torque sequence, and it's like, hey, these things are not tightening up as we wanted, so we'll give this thing another try, and I think we got this one pretty well legged. Point being is there's plenty of thread on here when you compare it to the original head bolt. Plenty of thread. You just got to do this little bit of almost using the bolt here as a gauge to set this one up.
Yeah, we like to see 3 threads showing, 2 at the very minimum. And using this method, we're going to get the thread showing that we need to fully engage that nut to give us the full torque value.
And we're just going until it's just going to meet here. Can you see okay that way?
There we go.
Okay. I'll put the 12 millimeter on here. This guy to stop. And that's just the slightest torque. That's going to torque, I think, without spinning the nut.
Probably so. And if it spins, if it turns, it's not going to turn much. Yeah. We already know that.
Yeah. That's got a nice little preload on it. I bet it's the 10, 15 foot-pounds or whatever. Yeah. But yeah. Let's say we're going to do this again. Cool. I think that's enough to keep the stud in place.
Yes, I do.
Torquing the main caps is a critical stage, and so we take our time. My dad reads off the sequence and values, and I do the grunt work. And although the thrust bearing was already set from the factory, we go through this step anyway just to make sure the crank is correctly settled fore to aft.
Quite happy with that. Doesn't it look pretty? Oh, it's gorgeous. Gorgeous. And I still often think, like, we will not pass this way again. And just take it in as you're here.
As before, we double check everything is torqued correctly before moving on to the next step.
Okay, so we've got rod and piston assembly number 2. And because we labeled everything when we took it apart, it means we've got the whole ring set for number 2, rod bearing for number 2. We kept all this stuff oriented, which on a new engine you probably don't have to do because it's not worn in at all. But definitely if you're rebuilding an engine, you want to keep track of everything. It's also, what's really nice is we've got these Total Seal. We sent all the secondary compression rings off to Total Seal and they shipped them back in the exact same keeping track of it sort of packaging as we sent it to them.
Getting the rings mounted starts with securing the piston and rod assembly. A bench vise is pretty handy for this, and just make sure you wrap the jaws in something soft.
I don't think there's a top and a bottom to that.
Yeah, I think it's all the same. You gotta have a ring expander tool and then use it real carefully because these things are actually really brittle.
Rings install from the bottom up. So the first to go is an oil control ring. This one is a 2-part assembly with a loose coil wrapped wire housed inside an open cage of sorts. Use the ring expander to install the cage and follow with the coil. As the name implies, this ring assembly keeps the cylinder walls lightly lubricated.
I think that'll do it. So,
now piston rings are really tough, but brittle pieces of metal. Always use the right-sized ring expander for your piston diameter.
Okay, group side down. All right, so you can see that's the secondary compression right there, this shiny silver. And then the secondary, and that's the part you get from Total Seal, this, what do they call it? I don't know.
It is the gapless ring.
It's the gapless, but they called it something else, like a bridge or something like that. Anyway, that's the 2-piece, and it's offset 180 degrees from each other.
They call it a rail.
Rail. And then this, here, that's the diagram right there, the second gapless ring. But you don't think that means that the gapless sits on the inside, like that's the outside of the piston. Other way around. Outside of the piston is over here, and so this is sitting on the outside of it. Last one is the top compression ring. There's always a little dot on the ring to tell you which end is up. So you get that inserted and use your ring expander. Pretty cool tool. Orientation on this one, according to the book, is on 12 o'clock on the piston. So basically the top of the piston. There you go. Piston just needs the rod just needs a bearing, and then we're ready to go into the block.
There are a lot of different ring compressor tools out there, but I really came to favor this tapered one from Summit. Take a minute to triple check the ring orientation and carefully draw the ring compressor upward. When I'm done, I load up all the rings with a heavy dose of 20W50. We get the little covers back on the rod bolts and rotate the block flat because, well, it's time to get the first of these 8 finely balanced assemblies dropped back into their respective bores. Y'all have heard me say this probably dozens of times before, but take your time. Guide the open rod end to its position on the crank, taking care not to scar the cylinder wall or journal surfaces. The aluminum piston skirt will sort of guide itself into the iron bore. Check that the rod is seating correctly up to the crank journal and gently press the piston into the deck of the block. Using your powers of mechanical sympathy, feel the oil control ring compress through the tooling and seat into the bore.
The first ring now.
The secondary compression ring follows, but will probably resist movement as it travels down the tapered neck of the compressor. It's probably going to need a push. Use a block of wood, or in our case, an old hammer handle, to gently drive the piston and ring assembly into the bore.
The piston's in the deck.
You'll feel the rod bearing meet the crank journal and see the piston almost flush with the deck of the block, and that's it.
20 years? 23 years?
There it is.
Yeah, that'll do it.
Now, are you ready to rotate up so we can...
Yeah, I think so. I think so. Let me... Now, numbers go up.
Numbers go up, so numbers match. Okay. Let me slide this into place.
No. You can't watch what you're doing. It has to be through the camera.
We build and install these assemblies one at a time, luxuriating in the details. It's funny, it's one of those repetitive tasks that actually isn't tedious and, well, I only get to do it once. It's almost meditative. Now we're just one step away from having a functioning short block. The cam and crank need to be tied and timed to one another. These engines came with timing chains and sprockets, which I'm replacing with the salvaged aftermarket timing gears from the 6.2 liter. They're just about the only thing that survived. I'm gently installing the drive gear using a brass dowel. The driven gear installs similarly onto the cam. The two gears are timed to one another using marks on the face of each, and with the idler simply slipping into the position between the two. And now we've got a short block, fully balanced and with a handful of nice strength and performance upgrades. This is an engine my dad and I have actually talked about building for a while. To build an engine is to enjoy the process and details, and, well, if we're doing it right, it's a shared experience. And while I hadn't anticipated building this engine, I'm kind of glad I had to. It gave my dad and I an opportunity to share yet another project together. And really, that's far more important than forged cranks and timing gears and all that other stuff. But by their definition, processes move forward, and soon enough, these deck surfaces will get covered with heads and these bores will go dark, up until the moment the injectors start firing. Thanks for being here, and until next time, take care.